Okay, so with this lecture, I would like to ask your permission for the recording of this lecture, and after this, it will be published on YouTube for your reference and for your additional resource preparation for your final assessment or test. Thank you. You can say yes or you could type yes on the chat box. And this is also all recorded. Thank you. Thank you for your response. Okay. Start. Okay, so once again, good afternoon. So we already done with the lecture on lesson 3. So we forward with our topic on variable scale subnet mask. So this is just way different from your topic in subnetting, because in this way we try to implement our CEDAR notation on a different amount of ports or bits that is will be available on each device. So start. So we going to end in server load balancing. So lesson 4, we consider now CEDAR or slash notation and subnet mask. We'll have some calculations and also computation of subnets and implementation of subnetting. So these are the 3 topics that we will able to touch up this day. So as a review, so class A and class B and class C is used to in IP addressing. So the exact calculation of number of hosts is 2 to the n minus 2. How do we get the value of n? So n is the number of bits in the host ID. And how do we get the number of host ID? So these are the numbers of zeros or 1. These are number of zeros, and network ID, you have the number of ones. Okay. So CEDAR notation is a compact representation of an IP address, and it is associated network mask. The notation was invented by Phil Karn in 1980s. Writing IP address with a subnet mask can be tedious. That's why yesterday, so we have an example, and it takes up a lot of space. What is important is that how many bits of IP address constitute the network ID, hence specifying IP address and its subnet mask with CEDAR notation. So in this example, we have this. So this is an example of a class C subnetting. So we have this example, and the first ones represents your subnets. So your number of subnets are considered n are from this point to this point. We have 2. So if you use the formula, so you will be able to determine how are you going to divide the values of each subnet. So you will have 4 subnets, and how many hosts per subnet. So the number of hosts is determined from the number of zeros. So we have 1, 2, 3, 4, 5, 6. So these are your number of all hosts. Okay, so this is 2 to the 6. So you have 64 hosts per subnet. So each subnet you will have 64 hosts. And in this example, we have we were able to see that we have 64 hosts starting our count from 0 to this point, and to this point, and at this point, and to this point. So these are your number of subnets. So this is your 4 subnets. And in your subnets, we have what we call uh, network ID. These are the name of your subnets. So you have this, and this. In this case, we have a valid host. So what are valid hosts? So valid hosts are the usable hosts that we could able to use. So out of 64 hosts in a subnet, we could use 62. So why? Because as you can see on the next slide, uh, the first value will be considered for your network ID, and for your next value, you have the broadcast. So these two are not being used. So that's why your valid host will start at 1 to 62, because you will use 0 and 63 inside the range. So at the same time, the same also with the others. So that's why we don't count the number of hosts as part the total number of hosts, because we will allocate it to your subnet number and your broadcast number. So as you can see, we reserve 2 IP address, so that's why the usable will be only 62 each host for this example. Now, as you notice, we have the same seeder notation, because this was implemented to divide each subnet into 4 equal parts. But how if we're going to divide this 26 or this subnet into different values? So that's why we now forward with our topic on slash notation. This is just a recall. And in this example, you have this as a static. This example is a static scale subnet mask, meaning our seeder notation doesn't change. So this would be the same in all parts, because we divide each uh, subnet into 4 parts. So this would be your the slash notation. Now, in this example, we have this class A. So we have this. So in Cisco, you're going to type this if you want to implement. So for class A, your uh, your count example will start at 1, and since we considered 18, so you put ones values from this start. So 1, 8, 16. So you have plus 7 plus 2. So you have 18. So this would be your uh, uh, identification that you could compute your subnet mask. Now, in this example, what would be your network ID for this example? For this example, your network ID will be this one, 10.0. Then your host ID will be what? Your host ID will be you have 255, and you have dot 192 that's 0. So because this is class A, so we only consider the first octet would be your network ID, and the other part would be your host ID. So any questions about this? So this is your host ID, sorry, network ID, and this is your host ID. So that's how you're going to compute for your subnet mask given the seeder notation 10.0.0.0.0.0. So any question about this? So you always start on the first octet, and you will consider the number of ones by checking the value of the seeder notation, which is 18. So you start your count here, and to the first octet and to the second octet, and the last would be the third octet. Now we will going to move forward. So we going to write the mask out in the binary. So and count the number of bits that are set to 1. So now this would be a class C example. So because we start with 192.168.23.0, so how are we going to compute for your mask for this example? Since IPv4 will only stop at 32 bits, so as you know, when we have 30 seeder, meaning you're just going to subtract 2. So this one is not allocated. What is allocated in this part is this only. So in this case, you have how many subnets you will have. So you raise this to n, and you raise this to what is the value? You have 2 to the 6. These are the number of ones. And you will have 2 to the 6 is, what is the answer? 2 to the 6. So you have 64, right? So you have 64. And how many are, these are the subnets, number of subnets. Subnet. How many are the hosts per subnet in this example? So number of hosts per subnet is checking the number of zeros. So it's again 2 to the n. So this is 2 raised to uh, uh, 2. So you have okay, maybe this 2 already. That's okay. And this would be 4. You have 4 hosts. That's per subnet. So this is dividing each into smaller parts. So that's it. And what would be your usable IP? For this example, you have only 2 because you have 2 to the n minus 2. So you have only 2 hosts to be used because the 2 were for your network number and your for your broadcast address. So at the same time, as you see the example on this side, So you just follow this, and you don't have any problem with the calculation. And if you try to practice it at home, so it's better. Try to put different value for your host address, and you will have this is for class C. Okay, but since we don't have enough time, so most of our example will be class C. If you want to learn class B, so there is another way for it in subnetting. This is an example of a class B. So you have the CEDAR notation. When you say class B, again, we consider only the first two octets. So this is your first two octets, and this would be your host ID. So in this example, this is your subnet mask, and you will have this as a result. You have this CEDAR notation based on the given. You need to convert this into binary so that you'll know what would be your CEDAR notation, because in this side, we don't know. So we don't know the CEDAR notation. So when you convert this, then you will have this. This is from this part to this part, this is your 240. And that is how you convert. And all you need is to count the number of ones. So 8 plus 8 plus 8, you have 24 plus 4, you have 28. So you have this CEDAR notation. And in Cisco, if you want to have it in Cisco format, so this is the format. In this way, you have this also. This is the same. So you so that you will not able to have problem with the setup of your subnet mask. So automatically, if you type this is the same as this value in Cisco. So any questions with this example? Okay. So we move forward. So in this example, so what is the answer? If you start with /20, what would be the size required for 60 subnetworks? When we say subnetworks, we are going to divide each into 60 subnetworks. So how do we start? So since we start with /20, so we need to count /20. This is 2 raised to the 0. This is 2 raised to the 1. This is 2 raised to the 2. And this is 2 raised to the 3. And this is 2 raised to the 4. And 2 raised to the 5. And this is 2 raised to the 6. And we need 60. So what do we not need here is 32. So 32 is lacking another 32 subnets. So the correct answer would be on this side. So we need /26. And there are 64 subnetworks that can be allocated on this side. Now, and another example, if you start your count with 10, and what would be the size required for 100 subnetworks? In this example, the same method that we did in problem 1. So you have, what's the answer? What's the answer? For this example, problem number 2. What size required for 100 subnetworks? So for this, we have 64 is lacking, so we will move for the maximum value, that is U128. So this is the number of subnetworks that can be used to 100 subnetworks. So you have 1, 2, 3, 4, 5, 6, 7, 8. So 8. Okay. Now for problem number 1 in slash notation. Now this is another problem. Now if you start with 21, how many subnetworks could you create that will contain 60 IP address? When you say 60 IP address, this means that this is your what? Is your number of. So if you start with 21, how many subnetworks could you create to contain 60 IP address? So what you're going to do first is to identify the value. So if you check, the maximum value that in IP version 4 could have is until 32. So this is, there's no 33s. So this is the last value that we could have. So in this case, so you will have values from your subnet. So to maximize subnet, so you need 60 IP address. So what you need is this value. And so if this is the value, meaning this how the value ends on this part. So at slash 26. So you disregard this value because this is the the size. So what will happen is, so you're going to go back to your problem if you start with 21. So if you start with 21, so it ends in 26. So if it ends in 26, so you start your count from 21. So if you start your count from 21 and end in 26, so how many sub networks are there? So in this case, you will have 32. So you have 32. So you have 32 subnets from 21 to 26. So the answer would be 32. So if it reaches this point, so half of it will be used. So the group size would be 192. And this is how do we get the group size? That is basis on your needs. So if you need 60 IP address, so you'll have a group size of 192 to be able to use from 21 to 26. So any questions on this example? Okay, so no questions, so we move forward. Now in this example, how do we solve for this? Given the following IP address, how many can you create to contain 50 IP address? So 50, first we look at our table. This is our main table for CEDAR notation. So as the same as before, as discussed. So what would be the maximum IP address that we could consider? So we will consider values from your this side. So 50 IP address, and since you start at 23, so where would we so where it would end to get 60 IP address. So since if you have 50 and you have 60, so it's still on the same range that we have. So in this side, so you start with 23 and you end with what? So you end in 26. So this is ends with 26. The same time also, this example, we end at 26 because we know the CIDR notation, we consider 60 IP address on this side, and we end at 26. So the answer of the subnetworks that we could create is we have 8. So we start our count from here. 1, 2, 4, 6, 1, 2, 4, 8. So this is the answer. Okay. So you always make your table. Then after that, you need to count the end value. So let's say, for example, you have 30 IP address. Okay, I will erase so that it's not going to. Okay, let's say we change the question. Let's say the same again. We start with 23, but we will change some important values. So we need only 30 connection in a laboratory, 30 IP address. In 30 IP address, so we need how many subnet for that? So to consider, you will have 27, right? So you have this. And given that it would contain 30 IP address, so you will stop your count from 27. So this is where you stop, and this is where you start. So it ends with what? 27. And what is the subnetworks that you will have? So you have, if you start your count from 23 to /27, you will have 16 subnetworks maximum sub. So 16 subnetwork. And on this side, if you have 30 IP address, so you use until /26, and each should have 16 subnetwork, and your number of size would be 32. So take note, all of the time we are even numbers because we need to divide each by. It should be, I think, all of this except for your except for 32-bit. So you have all even number except for this one because this is the maximum value of bits in your IP version 4. Now, another example in your slash notation. In this example, this is one other method. This is not the same as this one, which takes long time to answer. But in this case, you will have to make this table to answer the problem. If you start with 20, what size subnetworks you need to have 50 subnetworks? So if you start at 20, what size of subnetworks would you need? So to create 50 subnetworks. So when you say 50, so automatically you're going to make your assumption that number of bits should start in zero. So 2 to the first, 2 to the zero. So you have 1, 2, 4, 8, 16, 32, 64. So the expectation that we'll have, so we have the answer for this is you have on this side, and if you know that we can allocate 50 subnetworks in 64 IP addresses, so you just going to copy the n value 6. So you have 6 here, and you will have the answer. So you will end at slash 26 by adding 6. So slash 20 plus 6 is slash 26. So another example, problem number 4. If you start with 21, how many subnetworks could you create to contain 100 IP addresses? So in this example, this is the reverse part. So as you know, you start with 100 IP address. So what you're going to do uh, is to count. So how do you know that you will have 100 IP address? So you have this table, and this table will allow you to see if you have 100 IP address. So the maximum value that you could use is 128. And the notation for 128 is that you will have automatically 7. So even you're not going to use this, uh, you're just going to use reverse part. So you have you need just to have add 7, and you have slash 28 in the same way. So 7 would be the answer. So you have 7 subnetworks. That is from 1 slash 21 to 28. Okay, so you could use subtract, add, as long as you create this table. So in this example, this method slash notation using 2 to the n is much more easier as compared with this one. So which method you're going to use? So you could use this method, and you could also use this method. Now we have this example. Now, problem, if you start with 23, how many subnetworks could you create that we are going to have each 28? So you have 28 minus 23, that is 6. And you will have to check what would be so you have 64 IP addresses on this side. So you have 64 IP addresses. And the problem, if you start, so you have how many subnetworks? So you have 6, and this would be 64 IP address that you could use. 64 subnetworks. And if you start with 24, what size of subnetworks that you need to create 200 subnetworks? So if you start with 24, what size of subnetworks you need to create 200 subnetworks? So as we mentioned, we just going to continue the count at this point up to this point. So you have this point. So the answer would be the maximum value, that is 256. So this example, we have, so we have 24. In this case, you have, and you need 200 subnetworks, so you have plus 8. So you have maximum value is you have 32. This way you have this value. So in this case, how many hosts you will have? So in this case, no host you will have. So this example, you have just only the network number, but the number of hosts you could not have. But in this example, since you have 200 subnetworks, so you will have only subnetworks until 32, but no host inside. Depends on how you're going to have it. So the answer for this is this one and this one, or the other. Now, why do we subnet? So earlier, we calculated only on the fixed or the static length subnet. What is static or fixed? So as we mentioned earlier, this is an example of a static, meaning we have equally distributed subnet number. So we don't change this into 32 to 24. But on our next topic, this will focus more on the division. So to make this clear, first you need to start with your CEDAR notation. So your CEDAR notation will identify the size of your subnetwork. Now, if you start with 27, as we mentioned in our example, we don't have a starting point at 27. So, okay. So if we start at 27 and we end at 32, so the first starting point would be the whole 255. Okay. So if this is 255, 0 to 255, this would be, the next slash notation would be what? Divided by 2. So this would be 100. So 128, di ba? 128, 128 you have 256. So you have 127, and this another you have 127. Now for slash 29, so you divide this. This would be 64, or say 63. This is 63, 63, and 63. And if you divide 63 by 2, so you have 32, 32, 32, and until you have here 16, 16, you have your 4, 4, 4, 4. So this is how you divide your fixed subnet mask, fixed length subnet mask. So that's how we equally divide each value. So that's how important subnetting is, because you're not going to use all values. As I mentioned, you're not just going to create your own IP address, but you need to allocate specific IP address for the network. And at the end, you have your CEDAR notation, the number of IP address in the subnet network, and the number of sub networks. So usually in your activity in your laboratory number 6, so you need to show this on your laboratory number 6. I will post it. So you need to answer using this example because that is only fixed length uh, fixed length subnet mask. So that's easier compared to variable subnet mask. Now we move forward with discussing variable length subnet mask. So it means of allocating IP addressing resources to subnet mask according to why we need to have VLSM. So it provides benefits for real networks, mainly related on how you allocate and use your IP address space. Because mask defines the size of the subnet, so the number of host addresses in a subnet, so that's how we define a mask. That is the size of the subnet. VLSM allows engineers to better match the need for addresses with the size of subnet. And also the implementation of subnetting. So this is how we implement variable length subnet mask. Now, given example, so the use of variable subnet mask into real application. Let's say I'm going to give you an example that we could apply this. For this one, number of hosts. So likewise, if you want 23 hosts, so like this would be your office. This is office. You have 23 computer in the office, and on the laboratory, you have 60. So this would be laboratory. You have 60 computers to allocate, and you have 12 in the office. For example, in the 12 computers to be used in another, let's say, uh, finance department. So there are 12 in the finance, and we have 20 also in another office. You have, let's say, this is office 1, office 2, and you have also this one would be for uh, lab 1, and this is for your lab 2. And this one, you have 14 computers to be allocated for a certain value. So you have this, let's say, administration. So you have 14 computers to be allocated in that IP address. So why do we have variable length? What is the length? So as we know, this is the length of our IP address, 27. Then the second IP address is 26. The third would be /28. The fourth would be /27. And the fifth would be 26. And the last would be 28. How do we allocate the value? So I will erase to make it more clear. So we realize that every host have its application where to put these values. So at first, you need to allocate values with the larger number of hosts. So if you have, for example, 60 hosts, so why is it that you will not use this part? Because using slash 24 will make this occupied. So once you use this part, you could not use it for small IP addresses. So why is it we are not using slash 24? Because on that side you have 256 connections. And if you use this part, you could not use this part. You will use the whole block. Okay? So if you use slash 24, remember, you're going to occupy the whole block itself. So this would make us not able to utilize properly our IP addresses because we are referring to variable subnet mask. But why is it on our example? Why is it on our example that we use slash 26 only? As you know, in the fixed length subnet mask, we have this example, right? Why is it we use slash 26 here in the question? Why is it we use slash 26, all of this? Because this is a fixed length subnet mask, but it depends on the problem, right? So if you have a problem that is different from creating a number of hosts, so so this is another example. So using this example, take note, this example, how many are the number of hosts here? You have 60, so you have 64. So that's why we have slash 26, because we divide equally, we allocate each by having four subnets. So this is first subnet, second subnet, third subnet, and you have this fourth subnet. So that is the answer for this example. So we divide uh, this, the four subnets here represents the division of your network. So you cannot just say that you use slash 24, because in slash 24, you will use the whole subnet. And once you use the whole subnet, meaning you could not use this anymore. You could not divide this because you use slash 24. And once you use a variable length subnet mask, so you could divide each subnet into number of parts. So this is 64 hosts, and that's how we put here to identify the division. So first thing first, if you want to implement this, you need to check the large values. So we have the rank values. So we have 60. So this would be allocated for this 60. And we have this 31. So this would contain 31 hosts. And take note, you have each of this block is divided into 64, and you have 26. So 26 slash 26, you have amount that is equally distributed. So in this way, when you're not going to allocate this part, then you could use it for another parts that needs amount of host. So now, since we allocated already for 60 and 31, we finished allocating the values. Now we go for the second higher values of host. that is 23 and 620. So since we are looking for 23 hosts, we have 32. So if you divide this 60 into 2, so you have 64, you have 32, and you have also another 32 here. So one block is 32. So you could use this as for your 23 host. At the same time, since you're going to use slash 27, so you have here at slash 27, so meaning on the other part, you could still adopt this value. So you have 20 hosts for this, you have 20, and you have this one. Okay, so any questions? Now, since we need also the other parts to connect, so we have another connection that we need to establish. So we have 30, so we need to connect 12 uh, computers on this side. So you have to put here, there are 12 because each value here class is 32, and when you divide this 32 into 2, you will have how many? 16. So 16 plus 16, you have 32. And now you could use green for 12, and you also can use 14. This is 14 hosts that being allocated. So you have what are the vacant IP address that you can use. So this side is vacant, and also this side is vacant. So what are the vacant IP addresses? So this side is vacant, this is occupied, and also this side is vacant. So you have a spare IP addresses. And take note, if you want only to allocate for two IP address, you don't need to allocate it in the large, you need to allocate it in the smaller part of IP address. So if you going to allocate to 254, there are two numbers of sizes. So you're just going to use this size for your notation. And what you need, so you have the first IP address as your number of address and the broadcast address. So one IP address could be used in the 31st. Okay, so that's why we use this notation for router 1 and router 2 to make them allocated in these values, this area. Okay, so we move forward. Any more questions? Okay, this is module 7. So we have this value. Okay, one moment, please.
Okay, so any more questions? You have the module 7. So we end our lecture on this slide. And any more questions? Because you will solve for this module 7. Any more questions? None. So these are the summary for our lecture. This is only the thing that you need to identify. And I will have this recording after. So we finished discussing fixed length subnet mask and variable length subnet mask. And this will be helpful in our subnetting. Okay, so this is the final task that you will have. So you have until module 7 for this course. So any more questions before we end our lecture? And I will stop the recording. Hopefully it's not going to be difficult.